So I need a dust extractor, and I've been looking around a couple of designs out there, and they all seem to have a similar issue. Number one, you can't see what you're doing. Sometimes you can, most of the time you can't. Number two, they tend to machine their own brushes, especially when you have a big Z travel. There's no adjustment in them, which is annoying. And number three, they don't always work. So I'm going to try and solve some of these problems. Might not be able to solve all of them with my own dust extractor. So stick around and I'll show you how I built it. So this is what the CAD looks like. I haven't modelled in the actual brush itself, but essentially what it does is it gets mounted to this Perspex platform. I've machined the Perspex platform in 2 parts, only because I've got some 6mm lying around and I thought, hey, 6mm ain't thick enough, but 12mm might be, I'll just layer them up. The idea is that this platform moves up and down, like this, and it adjusts to whatever Z height I'm machining at. And it does that through these bushes. So these bushes sit on these rods. These bushes are currently made out of phosphor bronze. I suspect what's going to probably happen is this platform is probably going to maybe adjust itself to Z height, but then it doesn't really fall back down. And if that is the case, I'm probably going to swap them out for PTFE. To help it also fall back down, I'm going to put some springs in. So the springs sit through this hole, and then there's a keyway that will actually locate it in place. And the whole thing actually gets mounted through some magnets. So I've got some 4 posts over here, some neodymium magnets sit inside here, and then I've got a cast iron block which my spindle sits into. So this whole thing is basically on a quick release magnet system, which I think is going to be quite useful because, you know, when you're swapping out a tool or doing something like that, you want to get the dust extractor out of the way as fast as possible. That's pretty much it. So let's get into building it. So first things first, I want to see what I'm doing. So I'm going to machine up Perspex top shroud. So for work holding, I'm using some masking tape and some double-sided sticky tape. I'm using a single flute cutter here just to maximize chip evacuation from the actual part, otherwise you get your plastic welding up on you. I've put the feeds and speeds down below, but if you are doing this, just make sure you don't run the cutter too slow. You want your feed rate fairly high, otherwise you will have problems with your chip sticking to your part, or worse, binding up your cutter. So I finished these parts up on the drill press and they came out great. Happy I did the chamfer mill op because the other side was real sharp. If I was doing it again, I definitely would make this part as 1 part rather than 2, but I only had this material lying around, so all good. So I'm using 1050 series aluminium over here, and the stuff is pretty much 100% commercially pure aluminium. I think it's like 99.5% or something like that, which means it's absolutely horrible to machine. It's gummy, it sticks to the colour, it doesn't really leave the best surface finish. So if you are going to machine it, go for a single flute end mill. Make sure it's carbide and make sure it's sharp. Use loads of coolant if you can, and blast the chips out of the actual zone. Don't go too slow because this will cause the chips to heat up and then bind with the colour. Actually over here I'm probably going a little bit too slow. I'm using a depth of cut of 1mm. I find it works okay for a 6mm cutter, but I certainly could have gone deeper. However, the problem really becomes the chips welding to the actual material rather than, you know, the cutter not being able to cut through the material. So over here I have got the dust extractor installed. Things I really like about it is it's super easy to set up. I love the fact that the magnets are holding it to the cast iron block. That works really well for me. I've never had an instance where in which the actual dust extractor pops off because there's too much force. I'm using some plumbing fittings for the actual side of the dust extractor, and that also works. They're pretty flimsy, but they've actually held up pretty well. Things that don't work as well is the platform itself. It does adjust to the height of your parts, and you can see over here it's contour milling operation. It's holding in most of the dust. However, what it doesn't do is on big Z travels, it doesn't fully come back down again. And the reason why is those bushes that I've got, they're not sliding correctly, so I do need to swap them out for PTFE. I think once I do that, it'll probably be helpful. However, even having the actual platform just adjust to the actual height of your part on your first, Z pass, that's super helpful because it means I don't have to set it up myself. I can just go ahead and do it. But yeah, as you can see from this little snippet, this is actually, this is basically a part from my Y-axis. I'm going to stiffen that gantry structure, and essentially I'm going to cast that part in cast iron. So if you're interested in that, I'm going to have another video coming out on that. Hit subscribe, hit like, make sure YouTube advertises this video. But anyway, I need to swap out those bearings for PTFE, and I'm probably going to make another video on that, or just another snippet of this probably hopefully working properly, because as you can tell, with a big part like this dust extractor really isn't doing much, simply because the brushes are not engaging. So yeah, I'm going to take it as a half success. I've made loads of parts now, and I've kept a lot of dust in, so whatever I'm doing here is way better than what I had before. But I've got a little long way to go. Anyway, thank you for watching, guys. I hope you found that useful, and hopefully I'll see you next time.